So today we're going to be talking a little bit about eclipses. There's two types of eclipses, the lunar eclipse and the solar eclipse. And the biggest thing to remember when talking about eclipses is eclipse means to block or to shield from. So when I have a lunar eclipse, that means that the moon is being blocked and that it can't be seen because the light from the sun is blocking it. And a solar eclipse stands for the sunlight being blocked from the earth, and that's caused by the moon. So this top picture here would be an example of a solar eclipse, and the bottom picture here would be an example of a lunar eclipse. So we're going to go through this slideshow here, and we're going to talk about it, and hopefully this will answer any questions that you have. Here we go. A lunar eclipse happens when the moon enters into Earth's shadow. Since the Earth is much bigger than the moon, it will disappear from sunlight behind the Earth for a much longer period of time. Earth is always in the middle during a lunar eclipse. So the order that we have to have in order for there to be a lunar eclipse has to go Sun, Earth, and then the moon. So here's our sun. It's bright and yellow. We got a dark blue Earth, and then the white moon here. As you can see, these lines here indicate the light that is coming from the sun. And inside of here would be your umbra shadow. And this is the darkest part of the shadow. It's kind of like a dark tunnel where the light that would be getting to the moon is blocked by the Earth getting in the way. The penumbra, which is the light coming in this direction here, creates this little scissor clip here, this little angle, and that penumbra is a little bit lighter. So some light is getting through, but it's not very much. And this allows for a partial lunar eclipse. When the moon is inside of the umbra, you get a total lunar eclipse, and that makes the Earth appear an orangish red color, and it kind of looks like have you ever heard the term blood moon, where the moon is really, really red? So a lunar eclipse, you can have a total lunar eclipse, and that's only when the moon enters into the umbra part of the shadow, and a partial lunar eclipse is when it is in the penumbra. So a penumbra situation would be something like this, where a little bit of light is getting to the moon still, and you can still see it, whether it be looking almost like a crescent or a gibbous moon, or just looking a little bit darker in the night sky compared to when it normally would. And then when you have a partial, or that's a penumbral lunar eclipse, my apologies. A partial lunar eclipse is when the moon is starting to pass into the umbra, but is still partially outside of the umbra. And then you have the total lunar eclipse, and that's when the moon has passed completely into the umbra, and it's almost completely dark, and you see a little bit of a red or a orange or yellowish hue to it, and that is caused by some of the light hitting the Earth's atmosphere, and that light getting bent around the atmosphere and then hitting the moon. And the moon has to be in that full moon position, which obviously happens, once every 29.5 days. Since the Earth is on an axis and the moon is not perfectly in line with the Earth 100% of the time, we don't get a lunar eclipse every single month. Although it'd be much cooler if we did. A lunar eclipse, the moon often looks red, and that's because the light waves are bending around it. Now, they put the yellow here, but that shouldn't be yellow. That should be the bluish Earth, where you see the light coming in and it hits and it kind of deflects the light. And here's a better example of it. So I've got the Earth. The sun would be over here, shining, causing this side to be day, this side to be night. And as the Earth atmosphere is hit by light around the planet, it bends the light, and it forms almost like a rainbow. And when that light is bent, it hits the moon and causes it to look red, as you can see that here. So it goes from, our traditional white and dark grays to partial red and then super red. It is quite magnificent if you get the chance to see it. But the light is going to refract and bend through the Earth's atmosphere at this point here, and it creates almost like a prism effect. If you've ever shined light through a prism, you can see it change into a rainbow, and that red wavelength of light then gets projected onto the moon during the total eclipse. And it looks really creepy, but awesome. Now, a solar eclipse is on the other side. And this, again, is going to go sun, moon, Earth in a straight line. And the moon casts a shadow on the Earth, but the moon is way smaller than the Earth. So the amount of light that is actually being blocked is much smaller. So a solar eclipse, again, solar meaning sun, eclipse means to block. The moon is always in the middle. So it has to go sun, moon, and then Earth. Now, anytime we're talking about an eclipse, we still talk about the umbra in the same way as we did during lunar eclipses. So the umbra is the darkest part of the shadow, and this is a very, very small umbra. And the penumbra is the lighter part of a shadow. And yes, you do get darkness, but you don't get complete and total darkness. So in 2017 in Grove City, Ohio, we were in the penumbra of the shadow. So yes, it did get darker, but it wasn't the complete and total umbra. The closest location to us, we would have had to travel down to South Carolina and I believe parts of Georgia. But let's just stick with South Carolina because I know that for a fact. I almost did. Should have. A total solar eclipse when the moon's umbra is cast onto the Earth, and the partial solar eclipse is when the moon's penumbra is cast onto the Earth. So a total solar eclipse, it occurs, but it's very regional. It's very, very small. And the path is usually going to travel because the Earth is rotating very quickly. For the total solar eclipse, even when there's a total solar eclipse, you still see the white light around the moon. Because yes, the moon does create a shadow on the Earth, and you could be in the umbra, but you would still see what they call the corona, which also stands for the crown. And that's that white light that is out and around the solar eclipse. A partial solar eclipse occurs in the lighter areas surrounding the area of totality. So the sun will appear to look like this. Now, even when the sun is in a partial solar eclipse, you still can't look at it. The amount of thermal energy coming from the sun will destroy your eyes. That's why you need those special glasses, even when it is an eclipse. So don't look at the sun, even if it's in an eclipse. It's still really bad for your eyes. And those glasses, you can get them off Amazon, a 50-pack of them for like $20. So don't hurt your eyes looking at a partial solar eclipse. And again, the path of the penumbra is going to be much larger than the umbra. So a total solar eclipse is only visible to those in the umbra. And this actually has it documented as a 90-mile diameter. So a 90-mile diameter for the kids sitting at home, we're talking about going from North Columbus down to Circleville. That's the diameter. That's the distance that you would be able to see it. It's not very large, and it happens pretty quick. And then everybody else in the penumbra would experience a partial solar eclipse like we did in Grove City when the eclipse happened in 2017. So actually, here is the path in 2017. And you can see you are here in Ohio. And Kentucky, Tennessee, South Carolina. They got a wonderful showing of this event. And of course, Oregon, Idaho, Wyoming, Nebraska, Missouri, Kentucky, Tennessee, and South Carolina. A solar eclipse. So what conditions are needed? Obviously, it has to be daytime. The moon has to be between the Earth and the sun. And it has to be in a perfectly straight line. As stated previously, in order to get a total eclipse, it's going to be right here on Earth. You're talking only a 90-mile diameter on average. A solar eclipse. So during a solar eclipse, the sun is blocked by the moon. How can the moon block such a large object like the sun? So the sun is about 400 times the size of the moon. The moon is 400 times closer to Earth than the sun. So the size difference gets canceled out because of the location of the moon and the size of the moon in relation to the sun, and just that distance makes all the difference in the world.